Hi, I'm Akshit Kumar. I'll briefly describe our work on the multisecretory problem, which is a joint work with Professor Omar Besbes and Yash Kanoria. The multisecretory problem is an online selection problem where given a sequence of T secretaries and a hiring budget P. As a recruiter, you have to select the top P candidates in terms of their ability. The challenge arises from the fact that the secretaries arrive in an online fashion, and as a decision maker, you need to make irrevocable hire or reject decisions. In this work, we will assume that the abilities are sampled in an IID manner, and this common distribution is known to the decision maker. In this work, we focus on the expected regret. This is a well-studied problem for the case of discrete and continuous distributions with bounded densities. However, both of them require different algorithmic ideas. So a natural research question is how to unify these disparate class of distributions and interpolate between them. In this work, we identify that there are two potential drivers of regret. First is the shape of the distribution, which determines how the types are clustered and try to capture the rarity of types. Second is the presence and absence of gaps. The shape is characterized by a parameter beta, which you should intuitively think of as the curvature of the density. The first insight is that as beta increases, we show that the exponent in the regret also increases, and beta is characterizing the hardness of the problem. The second insight is that the workhorse policy, called the certainty equivalent heuristic, which is optimal in the case of no gaps, incurs a large regret in the presence of gaps, and hence poses an algorithmic design challenge. This leads to our third insight and key algorithmic innovation, which is the conservatism with respect to gaps. And we show that with this idea, the performance of the conservatism policy is close to the performance of the optimal policy. The conservatism maxim is very simple and states that if your selection threshold is close to the gap, you use the gap as the threshold. Thank you.